So Avogadro's number, which we talked about before, is 6.022 times 10 to the 23rd. When we're dealing with elements such as iron or copper or helium, those are just atoms. And so 1 mole is equal to 6.022 times 10 to the 23rd atoms. If we're dealing with diatomic atoms or diatomic molecules such as chlorine or bromine or hydrogen, or compounds such as sodium nitrate, potassium chlorine, carbon dioxide, those are going to be molecules. So 6.022 times 10 to the 23rd molecules equal 1 mole. So it just depends on if we're talking atoms or if we're talking molecules, if we put the word atom or molecules. But notice it's the same number and they both equal 1 mole. So water is H2O. If I was trying to find the mass of water, I would need to look on the periodic table and find the mass of 2 hydrogens and 1 oxygen. That would give me a molar mass of 18.02 grams. Since that's a molecule, then it would be 6.022 times 10 to the 23rd molecules. Zinc is just Zn. So for my molar mass, I look on the periodic table and the mass of 1 zinc is 65.39 grams. Since zinc is just an atom, we have 6.022 times 10 to the 23rd atoms of zinc in a mole. And finally, hydrogen is not just H because it's one of the 7 diatomic, it's H2. Therefore, the molar mass of hydrogen is 2.02 grams, and we would use the word molecules when describing it. The types of problems that you would see are going to be similar to these. So just like before, we're going to start with the number and unit that was given. So we have 23.3 moles of mercury, and mercury is Hg. Since we have moles of mercury in the upper left, we're going to put moles of mercury in the bottom right. Remember that my units always have to be diagonal from each other. And I'm trying to convert moles to atoms. Well, I do know a conversion for moles to atoms. I know that there's always 1 mole is so many atoms. So plugging that in, I have my 23.3 times 6.022 times 10 to the 23rd atoms. I want 3 significant figures. So 1.40 times 10 to the 25th atoms. A common mistake is just writing 1.40. Make sure that you're looking to the far right on your calculator and writing down that E25 number, because that represents times 10 to the 25th. So go ahead and pause the video and try solving this one on your own. Restart if you get stuck or get an answer. So in this case, we had 7.45 times 10 to the 23rd molecules of aluminum hydroxide. So you should have put in molecules and moles. 1 mole is always 6.022 times 10 to the 23rd molecules. You should have divided, and we wanted 3 sig figs again. So in the calculator, it gave you this, but that 3 should have rounded up. So you should have written 1.24 moles. Make sure you're putting your answer in the proper number of sig figs and putting units on your answer. This next one's a little bit trickier because we're going to start with what's given, because that's how we always start. So our 13.2 grams of pure iron. So that's Fe. Whatever unit is given, I'm going to write next. But I'm trying to get to atoms. I don't have a conversion for grams to atoms. I have to go through moles. So I'm going to put moles of iron here. 1 mole is always equal to so many grams. Those grams we get from the periodic table. For iron, it's 55.85. Whatever unit is here must go in the bottom. And now I can convert my moles to atoms. Because iron is just an atom, that's why we see the word atom and not molecule. And again, it's 1 mole is 6.022 times 10 to the 23rd atoms. You're going to multiply and divide. And we wanted 3 sig figs again. Remember to be careful, not all of the answers will be in 3. So I want 1, 2, 3. That 2 is going to stay a 2. Don't forget the times 10 to the 23rd. Again, that's a super common mistake. So if you're struggling with these problems, remember that 1 mole is always equal to so many grams. We get those grams from the periodic table. That's the molar mass. And 1 mole is always equal to 6.022 times 10 to the 23rd particles. Those particles can be atoms, molecules, ions, etc., whatever we were talking about in the problem. 4.55 times 10 to the 24th molecules. So if that's molecules, I know I must put molecules on the bottom. And as we saw before, molecules, I have to go to moles. I can't go directly to grams. So I'm going to go molecules to moles. And it's always 1 mole. And for molecules, it's going to be 6.022 times 10 to the 23rd when it's with moles. If moles is up here, I know moles will have to go in the bottom. And I'm trying to get to kilograms. I do not have a conversion for moles to kilograms. I have a conversion for moles to grams. So I'm going to have to convert my moles to grams. And I know it's going to be 1 mole equals so many grams. And remember, we're getting those grams from the periodic table, like we've done before. So carbon dioxide, we have 1 carbon and 2 oxygens. So that's 44.01 grams. And finally, my last step is grams to kilograms. Well, kilograms is bigger, so for every 1 kilogram, there's 1,000 grams. So you can multiply 4.55 times 10 to the 24th times 44 divided by 6.022 times 10 to the 23rd divided by 1,000. Doesn't matter the order you go as long as you're multiplying the items on top, dividing the items on bottom. Make sure that you plug this one in because sometimes people mess this one up when they're trying to plug it in. So in the calculator you should get 0.33252 and then some more numbers. We want 3 significant figures, so that's 1, 2, 3. So that turns to 0.333 kilograms. You could have also written your answer in scientific notation. If so, you would have gotten that, because we moved the decimal over 1 place to the right. Go ahead and pause the video and try this one on your own. Restart when you have an answer. So your answer should have been 3.20 times 10 to the 22nd nanograms. If you got that answer, then you can fast forward. Otherwise, we wrote the number given with the unit. It doesn't matter when they give you scientific notation, you're just plugging that number in. Nano goes on the bottom. And we have to convert nano to grams because all of our mole conversions have grams in them, not nanograms or kilograms. So grams is the bigger value. So nano is 10 to the 9th, or 1 times 10 to the 9th. So currently we're at grams. We're trying to get grams to moles because we want to get to molecules. 1 mole is equal to so many grams. I'm dealing with sodium, sulfate. Sodium was a +1, sulfate's a -2, so they go together, 2 sodiums, 1 sulfate. So my molar mass should have been 142.05. If you messed up on your formula, then you would have messed up on your molar mass, which could cause you to get the wrong answer if that's why you didn't get 3.2. And finally, we have moles on the bottom, molecules on top. 1 mole is 6.022 times 10 to the 23rd molecules. All of my units cancel except molecules. I want 3 significant figures, so I've got to keep that 0, so 3.20 times 10 to the 22nd molecules. These next 2 problems are a little bit trickier because notice that you're starting with glucose, but you're trying to get carbon atoms. So we'll see why that's different at the very end. So the first step, we're going to start with our 16 grams of glucose. Since we have grams, we have to convert those to moles. And 1 mole is always equal to the molar mass. We have 6 carbons, 12 hydrogens, and 6 oxygens. So that's 180.18 grams. Then we can go moles to this is a molecule. So we have to go molecule of C6H12O6. For every 1 mole, we have 6.022 times 10 to the 23rd molecules. But notice in the problem, we don't want molecules, we want carbon atoms. So we need one more step. This step is the one that's different. For every 1 molecule of C6H12O6, I have so many atoms of carbon. So I look in the problem and notice I have 6 carbons. So that's what's going on top. Had the question read how many hydrogen atoms, everything would have been the same until the very end, and then it would have been 12 hydrogen for every 1 molecule. If it had said total atoms, I would have said 6 plus 12 plus 6. 6 carbon plus 12 hydrogen plus 6 oxygen gives me 24 atoms. And I would have put 24 atoms up here. So once I get to the particle world, I can go within the particle world, and that's what's happening in the last step. So I am multiplying and dividing, and I want 3 significant figures. In the calculator, you get this. We want 3 sig figs, so that 0 is going to have to round up. So 3.21 times 10 to the 23rd atoms of carbon. Go ahead and pause the video and try this one on your own. It's similar to the last one. So you should have gotten 1.62 times 10 to the 24th atoms of nitrogen. So just like the last problem, you should have started with your grams. Ammonium nitride is NH4 parentheses 3N. So there is a molar mass of 68.16 for every 1 mole. And every 1 mole is 6.022 times 10 to the 23rd molecules. Because again, we are dealing with a molecule. So for every 1 molecule of ammonium nitride, you should have had 4 atoms of nitrogen. This one was a little tricky because we have 3 nitrogens here plus another one there. So that was 4 atoms altogether. In the calculator, you should have gotten this number. Since we wanted 3 sig figs, that 8 rounded that 1 up, and that's why it's 1.62. Our final conversion that we're going to be dealing with moles is liters. 1 mole of any gas, so keyword there is gas, will occupy a volume of 22.4 liters if it's under STP, which is standard temperature and pressure. Right now, all of our gases will be at STP, regardless of if it says that, until we get to the gas unit second semester. So what you need to realize is 1 mole is 22.4 liters, again, of a gas. So here's a graphic that you may want to write down if you're struggling. We have number of moles in the center. Everything goes through moles. If I'm giving volume in liters, I'm going to convert to moles, and then I can go to either particles or I can go to grams. If I'm given milliliters, I have to first convert those milliliters to liters and then to moles and then whatever I'm looking for. If I'm given grams and I'm trying to get to particles, I'm going to convert grams to moles and then go from moles to particles, whether those particles be molecules or atoms. And same thing if I'm given milligrams and I'm trying to get to nanoliters, I'm going to have to convert my milligrams to grams, then grams to moles, moles to liters, and then finally liters to nanoliters. If you didn't write these conversions down before, you may want to write them all in one spot so you can visualize them. We added the last one on here. So 1 mole is equal to so many grams from the periodic table, the molar mass. 1 mole is 6.022 times 10 to the 23rd particles. And now 1 mole is equal to 22.4 liters of a gas at STP. Notice it's still always 1 mole for this unit. 1 mole is equal to so many grams, particles, or liters. So in this problem, starting just like we've done before, we're going to take our number, unit, and substance. And that was actually 34.0 on your notes. Since liters is here, we're going to put liters on the bottom. And I can go directly from liters to moles. Like we saw a second ago, 1 mole is equal to 22.4. So when I write liters, I'm going to put 22.4 with it. And 1 goes with moles. So I'm going to divide. And putting my answer in 3 sig figs, I get 1.52 moles. All right, let's try this one together. I'm going to start with my 45 grams of carbon dioxide. So if I have grams of carbon dioxide, I have to put grams of carbon dioxide on the bottom so they cancel. Remember that a minute ago we said that whatever they give you, you're going to be converting to moles. So I do have a conversion for grams to moles, so I can go directly to it. And my molar mass of CO2 is 44.01. So right now those cancel, I'm at moles. I'm trying to get to milliliters, but I can't get to milliliters until I get to liters. So in this problem, I'm starting at grams, and I'm trying to get to milliliters. So I'm going grams to moles, moles to liters, liters to milliliters. So I'm going to go moles to liters. 1 mole is 22.4 liters. So now I'm at liters. And finally, now I can go liters to milliliters. Liters is bigger, so it gets the 1, and milli is 1,000. Multiplying and dividing, we get 22903, and we want 2 significant figures. So that's my second sig fig. So it's going to round that up to a 3. So I get 23000. I need those placeholder zeros. And that's milliliters of CO2. You could have also written that in scientific notation. And that would have been times 10 to the 1, 2, 3, 4. 2.3 times 10 to the 4th. Either of those answers are correct. Go ahead and pause the video and try this last one on your own. Restart when you have an answer. So in this problem, we're starting with centiliters, and we're trying to go to milligrams. So we're going to have to convert centiliters to liters, then liters to moles, moles to grams, and then grams to milligrams. So that's my train of thought. The answer you should have gotten was 130 milligrams. If you didn't get that, then make sure that you watch and see where you messed up. So I have 75 centiliters. I needed to convert centiliters to liters. Liters was bigger, so it gets the 1, and there's 100 centiliters in a liter. Then I convert my liters to moles. There's always 1 mole is 22.4 liters. Then I'm going to convert my moles to grams. 1 mole is equal to the molar mass. Since we're dealing with helium, the molar mass is just 4.0. And finally, now I can convert my grams to milligrams. Grams is bigger, so it gets the 1, and there's 1,000 milligrams in a gram. I can cancel my units, make sure I did it correctly. I'm left with milligrams, so I'm multiplying and dividing. If all of your work was correct, and you plugged it in correctly, you should have gotten this in the calculator. We wanted 2 sig figs though, so that 3 is going to stay a 3. So it's 1, 3, and I've got to change this 3 to a 0 because it's a placeholder. Or I could have said 1.3 times 10 to the 2nd. Because both of these answers have 2 sig figs. But I couldn't leave it as 13 or 133 or 134. Those have too many sig figs or are not the same number.